So, okay, our first speaker is Dr. Jennifer Ngo-Anh. She has over 16 years of experience in ESA's Directorate of Human and Robotic Exploration. She has been working on scientific experiments on Earth and aboard the ISS. In recent years, she has been supported for the integration of new ESA member states, including Bulgaria, and she does champion making space science accessible and inclusive. Ladies and gentlemen, Jennifer Ngo-Anh.
Mm-hmm. Can you see now? All right, perfect. Good evening, everybody. Thanks for the lovely introduction, Lubomir. I'm very honored to be the first speaker of tonight and to be the first speaker of this event series. So many thanks for organizing everything. So with my presentation, I want to show you how space research is transforming life here on Earth. I know that space research is very often seen as distant and abstract, but I'm going to show you a different side of it. But before we start, let me give you a very quick mission briefing about myself. Lubomir already mentioned it. Just to put the stories that you are going to hear into context. I studied medicine and I studied neurosciences, and I joined the European Space Agency in 2006, so actually almost 20 years ago. And there, as Lubomir rightfully mentioned, I worked in the Directorate of Human Spaceflight and Robotic Exploration, which is essentially the place where we ask one fundamental question. And that is, how can we prepare humans to go deep into space? And also, how can we return them safely? So healthy, strong, and ready to continue living their lives on Earth as if they had just left for a vacation. I know what many of you are thinking. Humans traveling into deep space sounds like science fiction, but it is very real. And the examples that I'm going to share with you stem from that work that the European Space Agency is doing on a daily basis. So I'm going to tell you about research that is focused on enabling astronauts to survive, to adapt, and to thrive in space. And many of those discoveries don't stay in orbit. They are already helping people here on Earth live better, live safer, and live healthier lives. You may have seen in the news all major space agencies, including the European Space Agency, we are all working together to return to the moon. But this time we are not planning to do a quick pit stop. We do not want to plant a flag and then quickly leave before something bad happens. This time the goal is to stay. And through the Artemis program, which very fittingly is named after Apollo's twin sister, we would like to live and work on the moon in a safe and sustainable way. And the moon is not the final destination, it's actually a stepping stone for us for the next giant step. And that is sending humans on to Mars. I know it's ambitious, it's maybe even audacious, but if we are serious about keeping this goal or about reaching this goal, we have to do much more than just build rockets and habitats. We have to understand how to keep humans physically and mentally fit for months or even years in the most extreme environment that you can imagine. Now, a lot of people often ask us, should we really spend taxpayers' money on something that is so out of this world? It is a fair question, but the answer is yes, because what we discover for space very often comes back to Earth in unexpected and powerful ways. And by solving problems for astronauts in their very extreme condition, we are already now finding solutions for real challenges here at home. So I will take you on a journey starting with examples from space, and I will slowly bring you back down to Earth to the next speaker. So the International Space Station, as you might have heard, is one of the most extraordinary scientific laboratories that humankind has ever built. It's a symbol of international cooperation and engineering ingenuity. Assembly was completed in 2011. It has since then hosted a constantly growing research program. And as of today, the space station will continue to deliver unique results until at least 2030. We do not yet know what the most groundbreaking discovery will be, but what we do know is that it's already delivering benefits that we can see, that we can touch, and that we can use. And I'll give you a few examples. The vessel imaging experiment that you see here on this slide looked at changes in blood vessel wall properties of astronauts who went to the International Space Station, and they did so during and after the mission. What did the scientists find out? They found out that the blood vessels of the astronauts were significantly thickened during and after the mission, which corresponds to atherosclerosis processes here on Earth. Luckily, those changes returned back to normal within a few days or weeks after the astronauts came back to Earth. Now, those results are fascinating in themselves, but what is even more exciting is how we collected the data. So the astronauts who had no prior medical training, they guided ultrasound probes on themselves, following instructions from medical experts who were here down on Earth. So think about that. In the most isolated environment imaginable, we figured out how to bring medical diagnostics to people with no doctor in sight. And that is a really, truly amazing part. So that very technology is now being used to deliver care in remote areas of the Earth. For example, in disaster zones, in rural villages of underdeveloped regions. And it stems from a tool that was developed for space. Another beautiful example of how curiosity-driven science can have unexpected outcomes is this experiment. As you know, thermal regulation, so keeping our body at a stable temperature, is important for our well-being. Our organs are kept at a constant 37 degrees Celsius, whether it's in the middle of a freezing winter or on a hot summer day. And any disruption to this system can cause symptoms like physical and mental fatigue, or in the extreme case, can lead to either heat stroke or hypothermia. In fact, there's a dedicated World Health Organization expert group who recently concluded that it's inadvisable for deep body temperature to exceed 38 degrees in prolonged daily exposure to heavy work. So everything above 38 is actually not good for your body. Now, the Thermolab experiment investigated how astronauts regulate their body temperature in weightlessness, and they did that by studying how their bodies heated up and cooled down during exercise on board the space station. And the science team did so by measuring the core body temperature non-invasively from the forehead using a new technique, and they found some quite amazing results. So compared to on Earth, the core body temperature of astronauts rises higher and faster during exercise on board the space station. And they also observed that the temperature in general in astronauts stays higher by about 1 degree Celsius. That may sound like an odd curiosity or a fun fact, maybe something to impress your friends at dinner this weekend. But this space fever, as it is now called, is actually quite concerning. A 1 degree increase in body temperature requires already 20% more energy from your body, which if you translate that into food, is a lot. So mission planners need to know more about this phenomenon in order to estimate the required food supplies for long missions. And the Earth connection is also just as exciting. The temperature sensors that were developed for this experiment are now used to detect early warning signs of heat stress and fatigue in firefighters, in pilots, and athletes. So they have even made their ways into hospitals, offering a non-invasive, affordable tool to monitor patients on their wards. So what began with a question about how the human body responds to space has now turned into a practical tool for protecting people, not only in extreme environments, but in everyday settings as well. I'm disintegrating. So maybe the technician can help me? Does this work still? Can you still hear me? Okay. In space, astronauts lose about 1 to 2% of bone mass per month. Why? Because in weightlessness, the osteoblasts, so the cells that build bone, they reduce their activity, while the bone-destroying cells, they continue their work. The result is a net loss of bone mass. On Earth, this is essentially what happens during osteoporosis. The mechanism is the same, but in orbit, this process happens way faster. And this makes the ISS the ideal time machine for studying bone loss and allows us to see years of osteoporosis compressed into just a few months. Now, that research didn't stop at observation. It led to the development and also commercialization of a portable, high-resolution scanner called Extreme CT, which can now diagnose osteoporosis much earlier than before, helping to prevent fractures in millions of people. And because we are very often asked about non-space applications of our research, here's a fun example. The unique qualities of the device that I just told you about are also applied outside medicine and outside of space. For instance, in non-destructive imaging of ancient Egyptian mummies. So a project looking at astronauts' bones has not only advanced healthcare on Earth, but it has also opened windows into history, proving that space research can benefit us in ways we never would have imagined. My personal background is medical, which is why I presented lots of medical examples so far. But ESA and our international partners also conduct physical sciences research. And also here, research has led to applications on Earth. So in space flight, materials need to be lightweight, they need to be strong, they need to be resilient. And space pushes us to innovate, to design materials that are lighter, that are stronger, and more reliable than ever. And the best part of it is that all these innovations, they don't stay in orbit. They come back to Earth and improve the quality and reliability of products that we use every day. Now on Earth, gravity very often gets in the way when we process materials. There's buoyancy, there's convection, there's sedimentation, and those can all interfere with creating the perfect alloy or compound. Up in space, scientists can study materials in ways that gravity would never allow. And that gives them a clearer view of how metals, plasmas, and fluids behave in a pure environment. So our European scientists run a lot of experiments in the space environment with the vision of finding or creating novel materials that would be difficult or maybe impossible to produce on Earth. And there's one very concrete example. ISS research into metal alloys has helped to develop new turbine blades or turbine blade materials for the Airbus A320neo, resulting in quieter, more fuel-efficient, eco-friendly jet engines. The new blades are twice as light as the conventional nickel superalloys. My colleagues Maria and Camelia, who sit over there, we all live and work in the land of windmills. And the research that I just mentioned is also feeding into wind turbine design, helping companies build lighter, stronger, and more durable blades with less noise and better performance. So wind turbine companies are always looking for ways for making their turbines more efficient, like, for example, reducing their weight, reducing the weight of the blades, minimizing noise, and increasing the material's strength and lifetime. These are not just nice performance targets for a brochure. These goals directly translate into lower costs, higher energy output, and reliable operations in very harsh environments. So companies like Siemens in Germany and Vernier in France, they have a very strong interest in findings that stem from experiments that are being conducted on board the space station. And by studying how advanced materials behave in extreme conditions like higher radiation, temperature fluctuations, and mechanical stress, these studies help identify which composite materials are not only lightweight, but also resilient and long-lasting. So space research is not only helping astronauts to fly. What began in orbit in the pursuit of science is now helping us harvest energy more efficiently here on Earth. I learned this morning from Professor Tsetkov that Bulgaria operates a research station on the Antarctic continent, which is one of the most remote places on Earth. We also do that. The European Space Agency has supported research on the Antarctic Concordia station to simulate the isolation of space missions. The nearest neighbors of Concordia station are about 600 kilometers away to the north. The closest neighbors are actually the Russian Vostok station inhabitants. And that actually makes Concordia station more remote than the International Space Station, which is about 450 kilometers above our heads. So if you think about it, a stay on Concordia station resembles a lot the conditions that astronauts will have to face when they are on long-duration exploration missions. Crew members who are there are extremely isolated and confined. They have to live autonomously. They are exposed to the same people for a very long time. They are exposed to artificial light and cannot just open the door and leave. So Concordia station is actually considered as being one of the highest fidelity analogs on Earth for long-duration exploration missions. And that is why we have been using results from medical experiments to extrapolate for missions beyond low Earth orbit into deep space to prepare for long-duration missions with human crews. Now, you might be wondering, what does Concordia research have to do with life on Earth? Here's one link. There are many, but I'm picking one. To protect the very fragile Antarctic environment, all waste must be removed from the continent. which means that every drop of water and all materials must be properly treated before we remove it again. And together with the operators of Concordia Station, we developed a system to recycle the so-called gray water, so the wastewater stemming from shower, laundry, and dishwasher. And this system has been running at over 95% efficiency and has been running flawlessly since 2005. And you know what? This prototype is not just for Antarctica anymore. It's now being used in Moroccan villages. There is a Belgian monastery that brews beer. And since recently, a French hotel is also using this for sustainable independence. Again, space research created a solution and Earth found a need. And then finally, let me tell you about something that many will not expect. When you think about the dangers and all the challenges and risks of space and the space environment, dust, and specifically moon dust, is probably not the first thing that comes to your mind. But it's actually far more dangerous than you might realize. Because the moon has no atmosphere and a very weak gravity, dust never settles. So imagine you are on the moon and you breathe that dust in. With each breath, 1 million microscopic, razor-sharp particles entering your lungs. And think about the damage that it can do over time. Now, lunar dust is not like the dust that we find here on Earth. Moon dust is a very fine, abrasive, electrostatically charged powder that sticks to everything. To suits, so spacesuits, to instruments, to equipment, even internal spacecraft systems. It grinds, it scratches, and it contaminates. And when the Apollo 17 crew astronauts returned to their capsule, covered in moon dust, they forgot to brush themselves off. And that dust then infiltrated their lungs, triggering respiratory irritation, and even caused hardware malfunctions. We actually now call this lunar hay fever. But here's the interesting part. Our research into lunar dust is not only for future astronauts. In studying how to manage dust in space, we are uncovering valuable insights for Earth as well. For example, air pollution. Lunar dust research helps us understand how fine particles move and behave, and that improves guidelines to protect human lungs in cities, in deserts, and in workplaces where dust exposure is very high. There are also applications in agriculture. Dust on Earth can be a problem for farming. It can harm crops, it can block sunlight, and it can erode soil. So by studying how dust moves and behaves in space where conditions are very extreme, we can develop tools to predict, to manage, and to reduce the impact of dust in vulnerable regions. So in other words, by addressing alien dust, we are gaining tools and knowledge to solve very real problems and challenges here on Earth. Space research is helping us to breathe easier, to protect our crops, and to better understand our climate. What I've shared with you today is just a glimpse. Behind each of those stories are years of work, of collaboration, and of curiosity. We do not go into space to escape Earth. We go to space for Earth, to understand Earth better, to protect it more effectively and efficiently, and to improve life for all of us. That is the power of space research. It often starts with wonder. It can lead to innovation and can end with transformation here at home. Thank you for your time. I look forward to your questions later. And yeah, enjoy the rest of the talks.